Okay, hello everyone. I am welcoming you for this next session that on orthographic projection. So, in this topic, first we are going to learn the basic theory of orthographic projection, and then we will solve some basic examples. So, I will go to slide mode. Okay. Now, this is what you can see here that there are different types of lines you can see here, that outline, projection line, hidden line, center line, that we have learned this at the start of this course. So I will just repeat it and then you can solve. Okay, then this is what the application of different types of lines. So here you can see how the projection lines are drawn. Then these are the outlines, the circles, dimension lines, and other things you can see. These are the applications. And here it is a front view, here it is a top view. The holes are hidden, that's why it is required to draw by hidden lines. Okay. Now projection means everybody knows that in engineering drawing, the word projection means the image or that act uh, of obtaining the image of an object. The technical people often refer to this image as a view. So this is one of the example. Here it is a light source, object, and then screen. On the screen you will get the this particular image, and that image is called as a view. Okay, so you can see here, this is a school bus. Okay, so this school bus having different views here. I'll show you that these are the different views, and you can see this is a front view, then top view, bottom view. You can observe here, this is a bottom view, then this is a left hand side view, then this is a front view, right hand side view. So always do remember, left hand side view is always at the right side, and right hand side view always at the left side, because observer is looking from this side and drawing this one. Observer is looking from this side and drawing this side. So this is a left hand side view and this is a right hand side view. Getting? And then back view and top view. So here we are going to consider only front view, top view, and any one of the side view, either right hand side view or maybe left hand side view. Okay. So these are the 6 principal views we can able to draw for any object, but uh, the object can be properly defined with a three views only. Okay, so I'll not go into detail this part. So line of projection, line of sights, you know that line of sight and other things. So once you take the projection, you will get the view on the that plane or surface. That plane is called as a surface is called as a plane, and the image obtained on the plane is called as a view. So orthographic projection, it is uh, parallel projection parallel projection technique in which the line of sight are perpendicular to the plane of projection. So all the projection lines are perpendicular to the plane. So that is what the orthographic projection. Ortho means straight. Everybody knows that. We are using ortho option in the AutoCAD. So when you on the ortho, that you will get the straight line. Kindly stop this everything, whatever you are doing. Who is doing that? Stop it quickly. Do not do anything on the slide. Okay. Now this one is a plane of projection, also called as a frontal reference plane. That front view is called as a frontal reference plane. When that front view will get in the frontal reference plane, projection obtained on frontal reference plane is called as a front view, and then horizontal reference plane is there, so that you will get the top view in the horizontal reference plane. So HPVP, everybody knows that. So this is horizontal reference plane, this is frontal reference plane. Getting? And you will get the front view here, frontal reference plane, top view here. Okay. So this part you can see here. Now you can see this part. The one object is kept here. You will get the top view here. as a rectangle, and you will get the front view here. So when you see from the top, this surface is visible only. When you see from the front, this surface is visible only, green surface, and the red surface is for top view. So likewise, you have to project uh, this orthographic projection for this one. So there are four quadrant system, everybody knows that. And then in a first quadrant, when the object is kept in a first quadrant, that you will get the front view in the VP and the top view in the HP. Similarly, when object is kept in the third quadrant, you will get the front view in the VP and top view in the HP. Only thing is that horizontal plane is required to rotate in a clockwise direction 90 degree. That's why in the third angle projection method, the top view will be upward side and front view will be downward side of the XY line. And here in the front first quadrant, when horizontal plane is rotated by 90 degree, you will get front view here in the above XY line, and the top view you will get the below the XY line. So this is the first angle projection method. Third angle projection, we are not using second and fourth angle projection method because the views are merged in the second and fourth quadrant system. So you can see here that horizontal plane is rotated. So this I have completed, I think, at the start of the first chapter. So just I am going to revise these things. Okay, so you just go through this. So this is the basic. So this is front view, top view, XY line, horizontal reference plane, then frontal reference plane, or it is called as a vertical reference plane. So you can see here. Now here it is very important thing is that side view, how to draw the side view. Suppose observer is looking from for the side view, observer is looking from right side, then you have to draw side view in the left side. And if it is observer is looking from the left side, you have to draw uh, side view in the left hand side view. So that is what it is called as a left hand side view. Here it is left hand side view because side view is looking from this side and drawing this side. Front view is looking from this side and drawing on here. Okay. Now, next part here, you can see the front view, side view, top view, and this one is a side view. So plane of projection. In the plane of projection, you will get the side view, PP. So here it is HP, horizontal plane, vertical plane, and plane of projection. So that PP is, you will get side view. And that is what the left hand side view, because observer is looking from left side. That's why you will get the left hand side view on the right side, and right hand side view always on the left side. Okay. So third angle projection, I'm not going to detail this one. You can just check out this part, this one. Yes, Aftab Shikalgar, Aftab, just off your video. Aftab Shikalgar. Okay. Now, hello. Next part here. That Okay. So this is what for the third angle projection method that we are not going to learn. Now, this is a symbolic representation of first angle projection method and third angle projection method. So this is for first angle projection method and this is for third angle projection method. We are using first angle projection method, and this symbol is, you might have seen on the standard sheet of practical. Okay. So this is a first angle projection method symbol and this one is a third angle projection method symbol. So this is very important. At the end of the drawing, you have to draw this one, uh, that whether you have used first angle projection method or third angle projection method. We can find it by using these two symbols. Getting? Then there are different surfaces This one is a principal surface, inclined surface, skew surface, curve surface. There are different surfaces that are required to be learned. So when that surface is either parallel or perpendicular to reference planes, then it is called as a principal surface. So this is, you can see the parallel to HP, perpendicular to BP, perpendicular to VP. So this kind of surfaces are called as a principal surface. Okay. So inclined surface, everybody knows that 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 surface, it is inclined to one of the reference plane. So it is inclined to HP as well as inclined to BP, but it is perpendicular to PP. So this is called as an inclined surface. Then skew surfaces. Skew surfaces means it is inclined to all the reference planes, all the reference planes. So it's a kind of a triangular pyramid. It is kept in here, so that all these surfaces are inclined to all the reference planes. Only this, I think this one is also inclined. So all the surfaces are inclined to all the reference planes. So this is what the skew surface is. Then curved surfaces, cylindrical surface that are also conical surfaces are the curved surfaces are there. So these are, when you look from the front or side, you will get the always rectangle, and when you look from the top, you will get the standard shape like circle. Okay. So concept of hidden line, everybody knows that how to draw the hidden line. So the object is in front of you, and the arrow indicate that the observer is on this side. Arrow indicate that observer is on this side. So the front view you will get always from this arrow side. So for the front view, this surface is visible, this surface is visible. Top view, this surface is visible, this surface is visible. Side view is from this side. And when the side view is from this side, this is a right hand side view, always required to draw on the left side, because observer is looking from right side for the side view, and it is required to draw on the left side. So it is called as a right hand side view, need to be drawn into the left side. Okay. So you can see here that this is a front view, this is top view, and this one side view. Okay. So this is a right hand side view on the left side, and top view, only this and this surface is visible. So it is required to draw only these two lines. Front view, this surface and this rectangle and this rectangle is visible. So that's why it is required to draw only two rectangles. And the L shape is visible in the side view. So that's why in the side view only L shape is required to draw. But if I keep this object in a reverse way, so how the shape would be? Look at here. The shape would be changed like this. This line is hidden. Why it is hidden? Because if you see from the front, this C line, horizontal C line, this line is not visible here from the this side when we keep this object in a reverse way. So that's why it is must to draw the line with the dotted, means that is indicate that it is a hidden line. So this is what the concept of hidden line, everybody knows that how to show that hidden line and how to draw it. So in the orthographic projection, likewise, you have to prepare the hidden lines whenever the hidden parts are there. Sometimes you will find the object like this. Okay. So these red color indicate that these are hidden. But what happened? This B line is overlapped on this red line. This C line is overlapped on this line. Okay. So this B line is overlapped on this line, and C line is overlapped on this line. And this BC is overlapped on this red color line. So that's why these hidden lines are overlapped by some visible lines. So when hidden lines are overlapped by some visible lines, it is must uh, to show that hidden lines, visible lines here. Okay, it is must to show the visible lines here. Getting, and then next part is here cylindrical surface. So cylindrical surface, cylinder at hole at the center, cylinder surface at the hole at the center. So when we look from the front view, you will get inner circle or inner this circle as a hidden, and it is a throughout. So that's why we have to show it by hidden line. It is required to show in side view as well as front view. Okay. And when we keep the half cylinder here, so when we keep like this part is not visible in the side view. So that's why it is required to show by hidden line, and we have to take the projection from the inner circle, and then we have to show this by hidden line. Getting? Sometimes when we keep in a reverse way the same object, so what happened, that inner circle is completely invisible, so that's why not visible. So it is required to show by hidden line in the front as well as side view. So sometimes objects are prepared with some assembly. So if you observe here, so when you do the assembly, you have to show the views as a complete whole object, not like this. You have to consider this object as like this. And when you see from the front, you can find this one, this square, this triangle, and this square. So square, square, triangle. If you see from the top, this square, and this rectangle. So this rectangle is reduced because it is inclined, and you will not get the true shape here. So only this part you have to show, and you have to take the projection from this corner, and then you will get the rectangle. Then for the side view, this rectangle is visible here, and then one square. Getting? So next part, object as a single piece. You have to consider as an object as a single piece. Here also, when we keep like this, so the views are like this. If you see this one, this object, and if I cut this object, and if I ask you to prepare views, then how to draw it? So front view you will get two circles, and this step you will get by a line. Then top view, it is visible, this one. So this visible we have drawn, but inside this circle, this outer cylinder, the inner circle is not visible. So that's why we have to